Hello, I'm Dr. David Kordowitz, and welcome to Programming. Today we're going to be talking about data types and arrays in MATLAB. There are a lot of similarities between data types and arrays in C and C++ and those in MATLAB, but there are some distinct differences. Let's begin. Today we're going to start in the default workspace as is set up in MATLAB. In the center we have our command window, and on the right we have our workspace. So first let's go ahead and declare a variable. So let's say a equals 5. Doing this will create a variable over in the workspace named a, which has a value of 5. Now, this doesn't tell us what the data type is, and if we want to know that, we have to tell the workspace to show the data type. This is done by right-clicking on the top where it says name, value, and in the blank space afterwards, and selecting class. As we notice, this variable is a double. MATLAB always tries to make variables doubles if at all possible, because this keeps mathematics simpler. We can, however, typecast variables to other types. So let's say I say b equals uint 8 of a. What this will do is create a variable that is an unsigned integer of size 8. Now, in MATLAB, we define how many bits, in this case 8 bits, represent a given variable type. So we have uint 8, 16, 32, 64, all of those sort of things available, and then we have integers, which are ints. Double is default. We have characters and we have strings. These different variable types are relevant depending on the type of operation you want to do. However, MATLAB will not allow you to combine variable types and mathematical operations. This means that you need to cast your variables to be all the same type. So if I say a times b, it actually is allowing me to multiply it on this later version. However, really, if we want to technically be correct, it's going to be a times double of b, and that's going to give us a value of 25, which is a double. If you notice here, the answer is listed as uint 8 because it converted the variable that was a double into a uint 8 to do that mathematical operation. So this works very similar to C, how the different data types work and what the different data types are. However, things get a little bit different when you start talking about strings and arrays and things like that. A string is a discrete data type in MATLAB and not by default a character array. So we have a string, we can say, C equals, and in MATLAB we use the single quotes around strings. The double quotes are really never used for anything. And we could say hello world. And we'll put a semicolon after that. And what you'll see here is that we have in this case, we've ended up with a character that says hello world. Now, we can treat this as an array. We can treat this as a string. We also have cell arrays, which are very similar, but allow different lengths of words within the same array. So let's take a moment to talk about arrays. Well, first let's talk about ranges, which are arrays. So what we can do is we can say in MATLAB something to the example of d equals 0, 5. And what that's going to do is that's going to give us an array that contains the numbers 0 to 5. So if I hit enter, you'll notice over in our area over here, we have an array in square brackets that's 0, 1, 2, 3, 4, 5. The way this works is in intervals, the first digit is where you start and the second digit is where you stop if you only have 2 digits. Now, you can have more than 2 digits. So, for example, if I say e equals 0, 5, 50, this center number is going to be your increment. So what that means is I'm going to end up with an array that counts by 5s to 50. Now, it's too large to show, so it shows 1 by 11 double. But if I double-click on the e here, it'll pull it up in our spreadsheet style, and you can see it's 0, 5, 10, 15, 20, and so forth. So this is important because this creates arrays. Arrays in MATLAB work a little bit different, but very much the same as they do in C. Let's start with the idea that arrays in MATLAB are row first, column second. C, if you remember when we talked about it, it's column first, row second. So it's reversed, and it will be confusing when you're trying to do both programming languages at the same time, so I don't recommend bouncing back and forth until you're really comfortable with both. In MATLAB, we can also call individual elements of the array with the parentheses. So let's say I say e of 5, and I push enter, I get 20. That is the 5th element in the array. Now it's important to note, if I say e of 0, I'm going to get an error. This is because arrays in C start with 0 and arrays in MATLAB start at 1. So in other words, if you say you want an array from 0 to 50, you're going to have 1 through 11 instead of 0 through 10. This should make some sense when you think about it as far as counting and accounting for where things are in your array. Now, there's a few other ways you can deal with arrays, and multi-dimensional, single-dimensional, any of that sort of thing. You can build arrays by saying something to the effect of d equals square brackets d comma 6, for example. And by doing that, I'm going to create a new array d that is the old array d with the number 6 put on the end. If I push enter, you can see that it changed in the workspace. Now, in MATLAB, we can do things like this, and we can build arrays like this. It's considered bad form when you're writing a program, for example, to build an array as you go. So if we think about it, it's really bad to do an array that, say, looks like this. But let's take a look really quick at building some arrays. We're going to start simply with our classic close all, clear vars CLC. This is going to clear out our workspace to guarantee that every time we run this program that we get a clean run. After this, let's go ahead and create a while loop, or create any type of loop. So we're going to do a while, and we're going to use 1. So basically we're saying while true, so that is an infinite loop. MATLAB allows you to use while loops and for loops. I'll show you how to use a for loop afterwards. And we're going to say end. So instead of using curly braces, we use end to declare where the end of that loop is. So let's say that we have a variable x, and we're going to say x equals x, comma, and then we're going to call count. We haven't declared count yet. We're going to say at the top count equals 0. And we're going to come in here and we're going to say count equals count plus 1. So what that means is we're going to start with 0, and then we're going to keep incrementing up until we get to, well, in this case, forever. So we need to put a break condition in there. So I'm going to go ahead and use an if statement. It works exactly the same, although the parentheses are not necessary. The only difference is for else if, it is one word instead of 2. So we're going to say if x is greater than 100, break. We also end our if statements with an end command. So now this should make some logical sense. However, there's still a problem with this code. Let me run it and you'll see. So what happens here is we're saying x equals x comma count. Well, in the first time around, x doesn't exist. So we need to make x exist, and we could do that simply by saying x equals square brackets. This is going to create an empty array that we can work with and build as we go. Unlike C, we could keep building the array as we work through things. And this shouldn't be x here, this should be count. And so if we look on lint over here, we have an orange box, and the orange box is telling us that x appears to change every loop iteration. We should consider pre-allocating it. But in this case, we're not going to do that, and what's going to happen is it's going to make the program run just slightly slower than it would otherwise. So if we run this program, for example, now we're going to get 0 to 101. It's going to end when it's greater than 100, and we're getting 101 values in this x variable. That makes sense. It is 1 by 101. In other words, it is 1 row and 101 columns. So if we display this variable out, we can double click on it and see it in the display here. It is a row vector. If we hit X down here, we can display it, and it's going to show us all of the columns going across. But let's say we wanted to add a second row. We can do this actually quite simply using a second index. So let's say, for example, we say x of, and we want to do a second row, and we're going to say count plus 1. The reason we have to say count plus 1 is because at the first case, it's going to be 0 because we start the count at 0. So 0 isn't a valid index, so we need to increase by 1 to go through that. So we can say that this is example equal to a random number and load it up. So let's run this. And it says to me that dimensions of arrays being concatenated are not consistent. And that's because this count here is only a single variable. So let's instead say count, and we're going to use a semicolon to get to the next row, rand. And so what we're doing is we're creating an array inside the array. So let's try this again, and we run this, and now we have a 2 by 101. If I double click, you can see that the 2 by 101 has a second row that is a random number. So what if we want to look at this? The plot command really is our friend here. So we can say, okay, well, once this runs, let's go ahead and plot our x of row 1, which is our indices, is going to be our x value. So 1 comma colon. Colon tells me I want all values in that array. I can then say x of 2 comma colon, and that's going to give me the second set on the y-axis. Now if I run this, I'm going to get a graph, and it's going to appear off screen, so I'm going to drag it on. You're going to get a graph that's going to show you the random numbers that we've just collected. It's really that simple to plot things out, and you can see that they're always going to be between 0 and 1. This is how the random number generator works in MATLAB. So this is a general idea of visualizing an array that you've created. So you can create arrays, you can create variables, and you can visualize those. You can also do ranges within these. So if I only want to look at the first 10 values, for example, I can say 1 to 10. And I can say 1 to 10. And if I run that, my graph gets a lot simpler, and it's only 1 through 10. It's only 10 values between 0 and 9. So in a nutshell, this is kind of how variables work. Let's show you one more thing here, and that's how to use a for loop. For loops are actually quite simple in MATLAB. Let's make a for loop, and let's say we're going to use n as our index value, or we can use count at this point. So let's use count equals, and now we give it a range. So let's say we want count equals 1 to 10, or 1 to, let's say, length of x. So we're going to start adding a third column or a third row onto x. And to do that, we're going to say x of 3 comma, what we're going to say 3 comma and count is going to be equal to 1,000 or let's say 10 times rand, and that's going to be our value. We're now going to say end, and what's going to happen is each time through, count is going to increment through from 1 to whatever the length of this is, and then it's going to add that third row. Let's add an additional plot line on. So I'm going to do x of 1 comma 1 colon 10. Now note they have to be the same length, and then x of 3 comma 1 colon 10. And now let's plot this. And now we have a second line on our plot, which is the other variable. And if you notice, I multiplied it by 10, so the range here is 0 to 10. So in a nutshell, that's how for loops work, and we've shown how variables work. Now it's important to note that mathematics in MATLAB, which we'll go over in the next video, follows matrix math rules. So what that means is you have to be careful how you do your mathematics. Thank you for your time today, and see you next time.